Today's section is on rational functions. First, we want to be able to find the vertical asymptotes, both graphically and algebraically. So graphically, we just look at the graph. The vertical asymptotes are anywhere the graph is undefined. So where you can see things going in opposite directions here, like here, and over here, the graph is undefined at those spots. So this one on the left, that's at -6, and on the right is at 6. So the graph is undefined. There's vertical asymptotes at x equals -6 and x equals 6. Now we can also find the vertical asymptotes algebraically. And to do that, we want to see where the graph is undefined. And rational functions are undefined anywhere the bottom of the fraction, the bottom of the rational function, is equal to 0. Or we want it to be not equal to 0 because that's where it's undefined. So we just set the bottom of our fraction equal to 0. And we can see, just as we saw in the graph, that our vertical asymptotes are at x equals -6 and x equals 6. Now keep in mind I wrote x equals. If you just put -6 and 6 on your graph or on your assignments, you're not going to get full credit. Reason being, the vertical asymptotes are lines. And to make it a line, you have to say x equals out front. X equals -6 is a vertical line. For this one, we want to find the horizontal asymptote. Now, horizontal asymptotes, there's some rules here. If the degree of the top is less than the degree of the bottom, then the horizontal asymptote is automatically y equals 0. If the degree of the top is equal to the degree of the bottom, then the horizontal asymptote is the leading coefficient of the top over the leading coefficient of the bottom. Let's see, I'll just put LC top over LC bottom. And if the degree of the top is greater than the degree of the bottom, then there's no horizontal asymptote. But there could be a slant asymptote. So in this case, we can look and see that the degree of the top is 1, the degree of the bottom is 2, so the degree of the top is less than the degree of the bottom. The horizontal asymptote is automatically y equals 0. Now, you've always heard probably that asymptotes are never crossed, and that's the case most of the time. But when it comes to horizontal asymptotes and slant also, the fact is that they can be crossed. It's just that either end here is getting closer and closer to the asymptote y equals 0, the line y equals 0, without ever being crossed. Okay? So it is crossed at some point, but the other two ends are still getting closer and closer and closer without crossing. Again, make sure you write y equals because it is a line. Find the horizontal asymptote here. Well, the degree of the top is 3 and the degree of the bottom is 1. So that means there's no horizontal asymptote. And you can look at the graph and see how You wouldn't have anything horizontal where things are getting closer and closer. Now, as far as a slant asymptote is concerned, to find a slant asymptote, you divide, use long division. So we'd have x plus 3 divided into x cubed plus 7x. I don't think you're asked to do this in your assignment, but I'm going to go ahead and do it for your benefit later on. So x would go into x cubed, x squared times. X squared times x is x cubed, and x squared times 3 is 3x cubed. And I forgot, I have to put a 0 x squared there. X squared times 3 is 3x squared. And then we subtract, so we have negative 3x squared. And I forgot to put back my plus 7x. And then x goes into 3x squared, negative 3x times. Negative 3x times 3 is negative 9x. Subtract. And x goes into 16x 16 times. Let's see, what is 16 times 3? 48. We could put plus 0 there. And when we subtract, we get a remainder of negative 48, but we don't care about the remainder. The slant asymptote is just what's on top, x squared minus 3x plus 16. And my guess here is that this is going to look something like this. Kind of ends up being a sort of a guide for the rational function, where the function is moving around and not actually hitting our slant asymptote. Find the horizontal asymptote for this one. Let's see, the degree of the top is equal to the degree of the bottom. So that means that our horizontal asymptote is the leading coefficient of the top over the leading coefficient of the bottom. Now, the only trick with these is to make sure when you're looking at horizontal asymptotes that your degrees are in order on top and in order on the bottom. Because if not, you're going to pick out the wrong thing. So the horizontal asymptote would be 4 over 2 or y equals 2. And so we can see right here how both sides are getting closer and closer to y equals 2. And one more to look at here. Find the whole and x-intercepts for the function 3 times x plus 1 over x plus 1 times x minus 2. Now, this is interesting, and you're not going to, when you graph these in Desmos, it's not going to show you the whole, okay? You have to move your mouse around. I've got a whole pictured here, but that wasn't normally on my graph. You have to move your mouse around to find it, or actually find it algebraically, okay? So to find the whole algebraically, you make sure that your rational function is factored, and it is in this case. And if there's anything that will cancel, like this x plus 1, set it equal to 0. And x equals negative 1, as you can see right here, is where our whole is, where x is negative 1. So the whole actually ends up being at, we can plug in -1 to find the y value. We don't need what we've canceled out, do we? So our whole is at -1, -1. That's where it is right there. And then it asked us to find the x-intercepts. So to do that, we will set the equation, set the function equal to 0. And actually, we'll do it after we've canceled because things canceled out, so we don't need to worry about those x plus 1s anymore. And when we do this, we end up with just 3 equals 0, which means there are no x-intercepts for this graph.